Ladies and gentlemen, very welcome to Green Connection. My name is Peter Larsson. I'm working for Scandinavian Airlines within the Green Connection project. We are standing at Oxford Aviation Academy at Stockholm Arlanda Airport, and what you see here in the background is one of Oxford's 737-700 simulators. And very soon we'll go inside, and my colleague Anders Bokvist will take over and show you the RMP approach we have developed within this project. First, a little bit about the general benefits of RMP approach. Firstly, you can adapt it very accurately along rivers and industrial areas, and by that you could save some noise for vicinity community surrounding our airports. And the other part, of course, is very important with the emission saving and also economy for the airlines with the fuel savings involved. Also, you have a very good track adherence on these approaches, so for air traffic controllers they are very predictable. They will fly more or less on a red line day in and day out, and they are a great enabler for what we call green approach, or to be able to fly continuous descents. And also, finally, if you're able to introduce these approaches at runways that are very much used by airlines, you will save flight time, flight by flight, and by that be able to utilize your aircraft fleet more and more. A little bit about this approach specifically. It's for runway 26 coming in from the western entry point, which is called LTOC in Stockholm terminal area. We have initial measurements that we will save up to 50 kilos of fuel on these approaches. They're also been adapted to be able to fit both 737 and Airbus fleets. They are so-called RMP 0.3. And by that, I think we should very soon enter the simulator and see the approach being flown in practice by one of our captains in SAS. Thank you.
Welcome to this SAS Boeing 737-700. We're actually sitting in a simulator at Oxford Aviation Academy at Arlanda Airport. This simulator is equipped with identical equipment as the real aircraft. That means that we have two flight management computers updated of the global positioning system, enables us to follow a prescribed track and also curved tracks. And we're also able to follow a programmed barometric descent called Baro VNAV operation that enables us to descend with almost idle power or low thrust setting. And this enables us to make curved approacher with low thrust setting, and that's called RNAV RMP approach. And this case will perform an RNAV RMP approach in towards Arlanda runway 26 at Stockholm. And by following this approach, we are saving track miles, and by that saving up to 50 kilos of fuel per each approach compared with the normal approach into towards this runway. Okay, we are starting the RNAV RMP approach in towards Arlanda runway 26, which is actually a curved approach, and focusing a bit on our instrumentation on the Boeing 737-700. Here we can see the track which we are following, and also the turn in towards the runway. We can see that we are in a continuous descent with our engines in idle, reducing our fuel burn and emission on carbon dioxide. We are now tracking the program track, following the information of the global positioning system. here we can see that we have a required navigation performance of 0.30 nautical miles, representing this area. And you can see that we are navigating very accurately. And the aircraft is tracking the track line and also following the programmed barometric descent path. And with a required navigation performance of 125 feet. We can actually see the actual navigation performance is within 64 feet, about 20 meters. Now we are turning, following the prescribed course, still with the idle descent. And now starting to configure the aircraft, still with idle power, passing the waypoint with a speed restriction of max 185. Now we're starting our final turn into the runway, still on the prescribed track. The required navigation performance is 0.30, and we're actually tracking 0.04.
2,500.
We're now 2,500 feet above the ground, present position, and we are lining up with the runway. Still descending through the programmed barometric descent path. And what I actually can see here is the glide path from the instrument landing system that we are not following. We are following the programmed descent path. And continuing to configure the aircraft for landing, reducing speed. And we are now lined up with the runway. The indication is that we are traffic the center line, and we can also see the track line towards the runway. And the final configuration for landing. And still an accuracy of 0.04 nautical miles in the lateral plane, about 50 feet accuracy in the vertical plane, and you see we are on the glide path.
1,000.
Still a concept program descent from our barometric info and nearing our minima where we have to see the runway.
+500. +100. Minimums.
Still letting the autopilot fly the aircraft towards the runway, tracking the localized from the ILS, but it's programmed from the GPS and also programmed descent path. Taking over.
50, 40, 30, 20, 10.